Good afternoon, guys. I'm going to make a video presentation about my last video. This is a continuation, and this is another example of this how to find draft and trim when handling weights involving large changes in mean draft. Okay, so this is form number 7 when you're indulged in large weights. Okay, so the density is 1.009, the drop is 4.9 forward, up is 5.20, and the main drop is 5.4, up 5.05. Okay, so I made an Excel form for you to follow. Okay, so this is the drop 4.9, 4.90, up drop is 5.20, and the main drop is 5.0, and the trim is 0.30, which is the same with this drop. Okay, so that is number 1. So we go to number 2. We will, with this main drop, you have to get the LCF. Okay, the LCF is negative 9.225. So let's go to the Excel. So your main drop is 5.5. So you go to the hydrostatic table, or you can scroll down and look for 5.5, and the LCF is negative 9.225, which is this one. Okay, or you can go to the hydrostatic table, then you put a drop of 5.05, and your LCF is, I got here 9.23, negative 9.23, and what we have is 9.225. So it's already run up in the Excel. Okay, then number 3, you compute for the mid center of flotation. Okay, you read this one, correct the mean drop to main drop at center of flotation. So mid drop, the center of flotation, and this is the formula. So I made it in an Excel form, and this one. So mid drop on center of flotation is trim times LCF over LPP. So our trim is 30 centimeters and LCF is 9.23. Our LCF is 9.23. This is this one. Okay, or LCF is 9.23 or 225. Go to the Excel. Over LPP is 215. Transpose the formula. So trim times LCF, that will be negative 276, divided by LPP, that will be negative 0.013, plus your mean drop of 505. You add this one, then your mid drop of center of flotation is 5.037 or 5.04, or displacement is 27594. That will be number 4. Okay, so we check the program. Number 4, the displacement is 27594. 27594, and that will drop will be 5037. Number 4. So we'll check. Just input this displacement 27954. 27954. 27954. Scroll down. put here 27954. 27954. And that will be 5037. That will be 5037. Okay, okay. 5037. I got here 5037. Then we have to take out, go up, go to number 4. There you are. 5.037. This is the displacement. Then you look for the LCB with this drop, okay? LCB is negative 1023. Scroll down. Or here we are. LCB is negative 1023. Negative 1023 LCB. Negative 1023, and your MTC is 7565. 7565. 7565. 7565. Okay? Or you go to the other side table. Then you have 5 of what's that? What's the drop? Is 50. Let me check. 5. Excuse me. 5.37. Is that correct? 5.037. Okay, I have to start the table. 5.037. Then you have your what are we looking for? I'm sorry. That will be LCB is 1023. LCB is 1023, and LCB, excuse me, LCB and MTC is 7565. MTC is 7565 or run off. Ready? Okay, that will be your cell form. So these two, you go up. That's number 4. That will be number 4. Okay, 7565. Then we go to the initial 5. Initial LCG. The formula is trim times MTC times 100 over tabulated displacement plus LCB. So that will be number 5. I got here in number 5. This number 4. Then this is number 5. Okay. Number 5, the formula initial LCG is trim times MTC times 100 over displacement plus LCB. Transpose. Your trim is 30 centimeters. Okay. Times MTC. MTC is 765 times 100 over your tabulated displacement, which is 27594, plus your LCB. LCB is negative 1023 over your displacement of 27594. So multiply this trim times MTC times 100. That will be 22695 over your displacement plus your LCB of negative 1023. Divide this one. That will be 0.22461 plus your LCB of negative 10.23, and the answer will be initial LCG is negative 940,754. That is in number 5. So number 5, what is number 5 here? Initial LCG is 9 for negative 9 for 420 420.72. 420.72. I got 440,754. It's this is I do this manually, and this is the result of my initial LCG. But I don't know how we got this number. But you try to compute it if you can get this right, the same number. Okay, so we go now to number 6. Number 6 is the initial displacement. So we have to correct the displacement to true displacement, which is initial displacement by multiplying the effect of density. So the initial displacement times your DD, or local density, over 125 salt water. DD is the dock water, which is this one, guys. Because you are floating in a density 1.009, so that is your local density, which is this one. DD is the water depth density. So you, with this displacement of 27954, multiply your local density of 1.009 over the freshwater density, then the resultant will be freshwater. Okay, so let's go to number 6. Number 6. Then here's number 6. Okay, you are floating in density 1.009, so your displacement of 27594, which is this one, multiply with your local density of 1.009 over salt water of 1.025. Your initial displacement will be 27163.26. That will be salt water. Number 6. How much is he got in number 6? I got 27163. We got 27518. Okay, just check this, guys, this formula, if you have the same results. Okay, just follow this procedure if we can get the same results. Now we go to number 7. Okay, we go to number 7, which is this one. Okay, number 7. So this is number 7 now. The same weights that we have in the last video presentation, I still use the same. The weights, the LCG, and the LCG moment. Now, since we have already the initial displacement, which is this one, initial displacement, just put it here. The LCG, or initial LCG, is 942, negative 942,072. This is one. Multiply weights by LCG, this will be LCG moment. Now what I have in my Excel, okay, the initial displacement that I have is 27163.2644, which is this one. Now what will be number 6? I think this one, number 6. 27163.26. That will be number 6. So this, I put it here. And the LCG is negative 9.408, which is this one. This is the initial LCG of 940,754. Okay, it's already run off. Multiply weight times LCG, that will be your LCG moment. And with the same weight that I have in the last video, which is all the same here, And my final displacement is 2316.864, and the final LCG is negative 7478, and this is the final LCG moment. Now, to get the final LCG moment, which is this one, divide by your displacement. The LCG moment is 469.8594, this one, and your displacement, which is this one, 62316.8644, and the resultant or final LCG is negative 7478. Okay, so this is your final LCG. And what you have, number 7, this final LCG is negative 7494. I got negative 7478. Okay, just take note, guys, what will happen in the final answer. So it's number 8. So we go to number 9. Go up. So number 9 will be applying the local density. Number 9. We go to number 9. So you have already your final LCG, and number 9 will be lookup displacement. Then you will have this displacement after applying this local density 1.023. Okay, I will explain it to you. Number 9, this displacement, guys, this final displacement are all in salt water. Okay, because you are already apply your weight, FODO, fresh water, perfect tank, hold 1, 3, 4, and 6. All these weights are in salt water. Okay, that's why the weights here, or the total weights here, or final displacement, is in salt water. Okay, so you have to apply your, how much would it be if you are floating in a density 1.023, okay, which is this one. So when you use the density 1.023 or the local density, what will be his displacement? This final displacement in salt water. Now, if she floats in 1.023, what will be his new displacement? This is what it meant here. So this is the formula how to apply the density. So displacement of your final displacement of 23168.8644, which is this one, okay, times your local saltwater displacement 1.025 over local density of 1.023. So transpose your final displacement times 1.025, that will be 63874.79, divided by your local displacement of local density 1.023, and your final displacement when floating and the density 1.23 is 62439. So this will be your final displacement. Okay, and what will be the corresponding drop of this displacement? The corresponding drop will be 10.308. Okay, so let's check number 10. Number 10 will be his corresponding displacement of floating in 1.023 is 62794, and I got 62439. So we have a big difference. And what will be the corresponding drop of this 62439 or 39 is run up? The corresponding drop would be 10.308. What will his drop here? His corresponding drop should be 5.0 5.037. That will be, how much did I have here? Double check this one. 10.08. Okay, 62438.7. 62439. Okay, put here 62439. 62439. Okay, so I have here 62438.7. The corresponding drop is 10.308. 10.308. Okay, and this local density will be 1.023, and what will be his LCB? Okay, LCB, that's number 10, and he got number 10 here. 10 is final spin drop of 5.07. 5.07 is way back here. 507. I think I have here. Let me check, guys. 507. This one. That's already in mid number 4. So this should be 10.308. This should be 10.08. Why? Okay. Later, guys. That will be that should be how much I got? 62439. 62439. Okay, 62439. 62439. 62439. That will be 10.308. Okay, 10.308. This should be, and this should be was 62794. Okay, 62794. We could push this 62794. 62794. That will be 1036. Got here 10,362. Okay, and I got 10,308. What you have is 1036. Big difference. Okay. Okay. Now this is how it goes, guys. The answer to his draft or displacement, how I got this one, is this formula H33, which is this displacement times salt water, which is this one. So displacement of 2,3, this is what he says, what he do. Displacement, which is this one, times your 1.025, and I got here times 1.025 over your local density 1.023, and 1.023 here is J36. J36, this is this one. So this how he got this formula is this one, guys. This one. That will be number 9. And I got 62439, and he got 62794. So with this displacement, you put it here. We just put equals. Okay. Then you go up, click this one, and there he goes. Okay. 62794. 62794. 62726, and the corresponding drop is 10.363, and you will see here 10.363. Okay, so I got, with this drop of 62439, and my drop is 10.308. Okay, with this density. So I just use mine, guys. Just compare. So what he got, the LBC is negative 61. This LCB is negative 58. I got 61 here. LCF is negative 233. Negative 233. LCF is negative 242. MTC is 97984. 97984. 98245. Okay, and what will be his final trim is negative 5.58. This is trim by the head because negative. So my trim is, okay, number 11. Number 11 is how to get the final trim is LCG minus LCB minus your displacement over MTC over 100, which is this one, guys. So I have already this figure. That will be number, so we go to number 11. Oh, number 11 is not here. 11, to get the trim is displacement times final LCG minus LCB over MTC times 100, which is the same with this one. Okay, this one. This is the same formula. And I got here displacement. So my displacement is 64439 times LCG. What is my LCG is negative 748, which is this one, guys. Negative 748 or this one. Okay. Negative 748 minus LCB. My LCB is negative 661 over MTC. MTC is 7984 times 100. So you do the equation of this one first. Final LCG minus LCB, that will be negative 0.87. Okay, so 0.87 times your displacement of 62439, which is this one, 62439, over MTC of 979.839. This is MTC. Okay, this is 84 round up times 100. Okay, multiply displacement with your distance. That will be negative 54322 MTC times 100 would be 97893.9, and the trim will be 0.55 by the head. But what he has is the trim is 0.5813. Okay? And this is his final drop forward, up, and midship. He is trimmed by the head because forward has a bigger draft than up. So his drop is, has a trim of 0.58. Okay, which is the same with this one. Okay, but in my computation, I got negative 0.55 by the head. Okay, continue. Then you go to the change of drop forward, which is this one, guys. Change of drop forward. So after you get your trim, this one, so you go to number 12. First, you compute for the change of drop forward, which is the formula of 1/2 LPP plus LCF over LPP times your final trim. This is your final trim, okay? So this is the formula, guys. This one, change of drop forward is your 1/2 LPP plus LCF, okay, plus LCF over LPP times trim, which is times trim here. Okay, so okay, transpose the formula. So my LPP is 215. What is 1/2 of 215 is 107.5. That is 1/2 plus your LCF of negative 242. What did I get? Negative 242. LCF is negative 242 from this drop. Okay, okay, negative 242 over your LPP times your trim of 0.55, which is this one. Okay, so what you do first, add this one, that will be negative 106.1 over LPP, divide this one, then you get the value of 0.493488, multiply with your trim, and my change of drop forward is 0.27. Okay, 0.27. Then next, because you already did the change of drop forward, of course you will look for the change of drop up. So what's the formula? Change of drop up is your trim, this one, minus your change of drop forward, which is this one. So negative 0.55 your trim minus your change of drop forward, which is negative 0.27, and your change of drop up will be negative 0.28. Okay, so you have now your change of drop forward and you have now change of drop up. Now we will apply this one. So you put your initial hydrostatic drop of 10.308, got 10.31, 10 point, this should be 10 point, what is, okay, should be the same. Okay, now here how to apply this forward, change of drop forward and change of drop up. Okay, I'll explain it to you guys. Okay, take note of this one. Okay, I have a figure here. Okay, take note that your final LCG is negative 748, which is this one. Negative 74478, this one. Okay, and your LCB is this one, LCB of 661. This is your LCB, okay, from this drop or from this displacement. So you have now your LCB and your final LCG, okay. Following this program, this diagram, this is your vessel, this is the amidship of your vessel, okay, or midship, the amidship of your vessel. From amidship, moving forward, that will be negative. From amidship, going backward, or going back, that will be positive, or backward, okay. Since your F final FCG is negative 7.48, so it's negative, so meaning is somewhere in the forward part of your vessel. So from midship, you measure from midship going forward to your vessel, and you measure negative 748. So negative 748, that is your final LCG. So this will be your, from amidship going to this vertical line will be your final LCG, which is negative 748, okay. Now your LCB also measured from amidship going to forward because it's negative. The measurement is negative 6.61. So from amidship, you measure it forward up to this line, which is your vertical of buoyancy, which is negative 6.61. Meaning, the forward LCG is forward of LBC. So LBC is behind forward LCG or FCG. FLCG. Okay? So, what is buoyancy, guys? The rule of the buoyancy, the water is to push the vessel upward. The rule of the gravity of LCG is you have weight here, the weight will press the vessel downward because of the gravity of the weight. That's why it's called LCG. So the tendency of this forward part of your vessel is to go down because of the weight concentrated on this part of the forward of the vessel. So that's why your vessel forward will sink. Okay, it will go down. Now, the tendency of the buoyancy here, the vertical, the tendency of the water because of the buoyancy, this will tend the vessel to rise up. So rise up. So meaning from your up part, this will go up. So this will go up and this will go down. So it's a counterclockwise direction. So if this is a seesaw, a seesaw where in the playground where children are playing, if this end, forward end of the vessel will go down, of course this other part, opposite part will go up because it's like a seesaw. It will go down, this will go up. Now, take note of the rule. Okay, take note of the rule. The rule is, if LCG is above of LCB, now, where is LCG located? Is it above or forward? Is it above of LBC? No, he's not above. He's not behind, but he is forward. So LCG is forward. So LCG is forward of LCB. So he's ahead of LCB. Then you are trimmed by the head. Because, as I said, the buoyancy and the weight exerted by the weight, the tendency of the vessel is to go down. That's why you are trimmed by the head. This will go up and you will trim by the head. That's why if LCG is forward of LCB, so your LCG is forward of LCB, then you are trimmed by the head. So your trim is trimmed by the head. Okay? Now, that's why Your trim here, the value of trim is negative 55 because you are trimmed by the head. That's why it's negative. Negative because you are somewhere around here in the negative forward part of the vessel. That's why you are trimmed by the head. Okay? So let's continue. So you put the hydrostatic drop of 10.38308, which is this one, guys. You have defined the displacement, then what is the corresponding drop? That will be 10.308. Okay, in a density of 1.023, and this will be your hydrostatic drop of 10.308. Now you apply the forward density correction forward and density correction up. So forward is 27, negative 0.27, up is 0.28. Since you will have more drop, this will sink, forward will sink, meaning you have to add this one. So you add this one, the final drop forward will be 10.58, and subtract up, you subtract because up will rise up. I mean, this will rise up, so you have less drop here. You will less drop there, and that will be 10.03. So your forward drop is 10.58, your up drop is 10.03, your mean drop is 10.30, 10.30, and trim is 0.05. Now the direction of your, you will have, sorry, so this will be, you will have less drop here. This will be less drop. Up, less drop up, and you will have more drop forward. This will be more drop forward. Okay, you will have more drop forward because on the forward part, this will sink. That's why you have more drop, and the up part, this stern will rise up. That's why you have less drop here. Okay, and since the forward will rise up, you will have less drop here, and up drop you will have more forward, more drop here. Up we will have less drop because this will rise, this will sink. So forward is 10.58, up is 10.03, main is 10.30, and your trim is negative 5.5. And there's another solution here. Your hydrostatic drop is 10.308. You add your change of drop forward, so you have a more drop here of 10.58, which is same, minus your trim of 0.55, then your drop up will be 10.03. Okay, so this is what I have, and what is the result of the program. This forward drop is 10.65. I got 10.58, and my drop up is 10.03, and this drop up is 10.07. This mean drop is 10.36. My mean drop is 10.03. The trim is negative 0.55, trim by the head, and this trim is negative 0.58. Okay, so I suggest, guys, that you follow this procedure and see if it is correct, or if there's something wrong, you can correct it and do your own mathematics. Okay, so I will give a copy of this one so you will have your own evaluation if this my computation is correct or not, or you can follow, you can check if this program is correct. Okay, so I I will leave, I also will leave a blank form for this one for you to make a copy, or a copy and a blank form so that you can do your exercises and fill in the blanks as you study this procedure. Okay, so that's it, guys. If you like this video, please click the like button and please share if you feel like sharing it, and subscribe. And if you feel, if and don't forget to click the notification bell. Okay, thank you for watching and have a good day.